morning, GCA friends. We're going to take a few minutes this morning and work through some of our problems that are on the IA4 review. Remember that IA4 opens up next week, but we do want to take a few minutes and go through the review since that is a grade that counts towards your final average for 5th grade math. So let's get started. So the first question we're going to look at, and your questions might be in a different order on your review, but the first one we want to look at, it says, which problem has the same answer as 63 ninths? Remember, this is saying that I have 63 ninths, and it takes 9 ninths to make one whole. So remember, an easy way to do this would be divide the numerator by the denominator. So let's look at our answer choices and see if we have anything. I have 9 divided by 63. Well, that's not it. That's going to give me a fraction of a group. Here I have 9 times 63. I know that's not it. Here I have 63 divided by 9, which would get me to the correct answer. And this one is just 63 times 9. That's not it. So if they had asked me to solve this, which they didn't, I know that 63 divided by 9 is actually 7. So they didn't ask me for the quotient there, but I know that that would be 7. Okay, the next question says, which word problem matches the problem? And they've given us 2/3 times 7. Let me write that a little larger up here. Times 7. And so we just need to match the word problem here. A says, Mark has 7 gallons of milk. Ernesto drinks 2/3 of a gallon. Well, that's not really giving me a multiplication problem there. I'm taking out that 2/3 of a gallon. So B says, each week Mark drinks 2/3 of a gallon of milk. How much does he drink in 7 weeks? Well, that's 7 whole weeks, and each week he drinks 2/3. So that looks like that's a pretty good choice. Let me read the other ones. Mark has 2/3 a gallon of milk. Ernesto has 7 gallons. How much do they have together? Well, that together, remember, is a great signal that I am going to be adding. So that's not the problem I need. And then D says, Mark has 2/3 of a gallon of milk that he needs to divide. Well, that gave you a cheat right there. Among his 7 family members. How much milk does each family member get? So this one would look more like this. So B is our best choice here to match that problem. All right, here's one about a baseball team. This baseball team drinks 10/4 gallons of water during a game. Which mixed number represents the gallons of water consumed? Well, remember, there's 2 ways that we could do this. We could draw ourselves a model. So we're going to say that these are fourths. So I know there's 4 fourths in each whole, and I need 10 fourths. So let me count and see how many I have. Oops, put too many in that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's 10 fourths right there. And I know that I have 2 holes there, and then I just have 2 parts of this one, which would give me 2 fourths. Well, I know that 2 fourths can simplify to 1/2. So if you look at your answer choices, 2 1/2 is right here. If you just use the standard algorithm to do this, you would have made your numerator your dividend, and your denominator is your divisor, So I know that 4 will go into 10 two times without going over. So 2 times 4 is 8, and when I subtract, I get 2. So this 2 gets to jump up here and become, pardon me, the numerator. So here's my whole number, so 2 2/4, which is the same thing that I got here. And it's going to reduce to 2 1/2. So both methods get you to the same answer. Okay, we're going to move on to the next question, and this one is actually very challenging. So let's take a look at what we have. It says Carla and Diane have started a pet sitting company. They have a 25-pound bag of food. There are 13 dogs. If each dog eats 1/3 of a pound, how much food would be left? So I have to figure out how much food is going to be left over. I know that there is a 25-pound bag of food. There are 13 dogs, and each dog eats 1/3 of a pound. So to figure this out, the first thing I have to figure out is how much the dogs have eaten. So in order to do that, I'm going to need to multiply 13 times 1/3. And remember, to multiply by a whole number, I'm going to put that whole number over 1. So in order to get my answer, I'm going to say 13 times 1 is 13, and 1 times 3 is 3. Well, I have an improper fraction here, so I could draw out circles that each have 3 pieces, and I could say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need one more. 13. So that's 1, 2, 3, 4 holes, and 1/3 out of that last one. You can absolutely use the standard algorithm to figure that out. You could have divided 13 by 3. Let me do that over here. Let's see if we can get that on camera. And I could have worked it this way. And then this remainder here becomes my numerator. So I would have 4 1/3. So same thing. Okay, so the dogs have eaten 4 1/3 pounds of the food. I have 25 total pounds. So now I have to subtract 25 minus 4 1/3. Well, here's the problem. We haven't really learned to do this, to do addition and subtraction with fractions yet. So let's just take a look and see what we can figure out. I know that 25 minus 4 is going to give me 21. And then I need to take away 1/3 more. So if I have 21, I could draw out 21 holes, and if I'm going to take away 1/3 more, I know it's going to leave 2/3 left over. So I'm going to take 1 hole out of this, and I'm going to make this 20. And then I'm going to give myself, there's 3 little fraction bars. So I have 20 3/3 right there. I need to take one of those thirds away. So I'm going to take this one out, and that leaves me 20 2/3, which would be answer choice B. If you were able to figure that one out independently, good for you. That is definitely a tough problem. The next question says, at a pizza party, 5 people will equally share 3 pizzas. How much pizza will each person receive? Remember that the denominator is going to be how many people are actually going to be sharing. So that means that 5 is going to be my denominator. And how many things are they sharing? They're sharing 3 things. So my answer here would be 3/5, because remember that a fraction is actually kind of a division problem. This fraction, it's the same as 5 divided by 3. So that would be 5 pizzas divided by 3 people. So your answer here would be D, 3/5 of a pizza. The next one, let me move it up here so we can see. Okay. This one says, without multiplying, tell which product is larger and why. Well, let's look at what we even have here. We have 6 times 1/2, or I have 4 times 1/2. Well, just think about the mental picture of that. If I have 6 1/2s, so if I did 6 little fraction bars here, oh boy, I'm running out of room. Let's see if I can scoot this over a bit. So there's 1, 2, 3, 4, 5, and we'll put one over here, 6. So there's 1, 2, 3, 4, 5, 6. There's 6 halves. I know that that would equal 3, but remember it said don't multiply it. Actually, just use what you know. Then 4 halves is going to be only 4 of these with 1/2 pieces. Oh, my last guy's off the camera there. Sorry. Okay, well, he's kind of on there now. So let's look at our answer choices. This says, which product is larger? A says 4.5 because 1/2 is less than 1. Well, I know that the 4.5 is not going to be larger. It's going to be the 6.5 that's larger. So it can't be A. 4.5 because 4 is a whole number. Okay, well that's not even comparing here. And I know it's not 4.5. So my last 2 choices are 6.5, so let's see which has the best reason why. 6.5 because 6 is greater than 4. Well, that's a very true statement, and that is why it's larger. So that's a possibility. And then D says 6.5 because half is less than 1. Well, that's not why it's making it larger out of these 2. So your only really good answer here is C, because 6.5 is, or 6.5 because 6 is greater than 4. All right. So here's our next question. If the shaded amount of a bar representing 1/4 is divided into 5 equal parts, what is the fraction for one of these parts? Well, I can draw this out here. So I know I need fourths. So I have 1/4 here, 1/4 here, 1/4, and 1/4. And then it says each of those is divided into 5 pieces. So let me divide these guys. All right, so now that's 1, 2. I'm not very good at dividing here. Okay, so there we go. Each little piece is now each fourth is now divided into 5 pieces. So that gives me 5, 10, 15, 20. So I have a total of 20 pieces here. What would one piece be worth? It would be worth 1/20th of the whole bar. So that would be answer choice B. Okay, the next question is similar. It says, after a birthday party, 1/4 of a large cake was left. If this piece of cake was shared equally among the 6 people, what fraction of the whole cake did the person eat? Okay, so here is my cake. That's a big birthday cake. And so I know that it was split into fourths because there's only 1/4 of it left. It tells me up here 1/4 was left. If that piece is shared equally among 6 people, so I have to chop each of these into 6 pieces. Now remember, I have to acknowledge that there was a whole cake to start with. So I have to cut all of it up, even if they're imaginary pieces at this point. So how much would one piece be worth? So I know that there's a total of 24 pieces here, because 4 times 6, so there's a total of 24 pieces. So one piece of it would be 1/24, which is B. All right, the next one says, if you know that 20 times 15 equals 300, what do you know about 40 times 15? So let me write this over here. Sometimes I need to write things out. And then they've given us 40 times 15. Well, the only thing that changed in these problems is I went from 20 to 40, so I doubled. So if I doubled, oops, and I'm off the screen. There we go. So if I doubled this, then my answer is also going to double. So I could write times 2 here. So my answer would double as well. So the first answer choice says it's 2 times 300. Well, that would be correct because we just doubled it. So let me check that one. That one makes sense. It's half of 300. No, because we're not dividing it. It didn't get smaller. It's 20 times 300. Well, that doesn't make any sense. Or it's 2 more than 300. 2 more than 300 would be 302. So just be careful with that. So these 3 don't make any sense, but A would be your best choice here. Okay, the next one says, if Mike divided 42 ounces of soap at his job equally into 9 soap dispensers, what is the weight of soap in one dispenser? So they're wanting to know what is the weight in one dispenser. Mike has 42 ounces of soap and he's splitting it equally into 9 soap dispensers. So what that tells me is that I have 42 ounces of soap and I am splitting it into 9 different things. So I made an improper fraction here, so let's use just the standard algorithm method to get this into a mixed number. So if I look at this, 9 times what gets me close to 42? Well, I know that 9 times 5 is 45. That's too much. So 9 times 4 is 36. All right. So that would give me 4 6/9. Now, for those of you that are working ahead, you're already saying you can reduce this. So I have 4 6/9, and 6/9 I could actually divide that by 1 or by 3. That's like dividing by 1. So 6 divided by 3 is 2, and then 9 divided by 3 is 3. That's 4 2/3. So I have 4 2/3 here, and I start looking at my answer choices, and I get a little anxious because 4 2/3 is not even an answer choice here. So let me go back and see what could have possibly gone wrong. If I look at 42/9, I know it's an improper fraction. Well, I see that all of these are, this is a mixed number, this is a mixed number, this is a regular fraction, here's a mixed number. So let me see what would happen if I reduced 42/9 without making it into a mixed number. So if I divide, let's say, let's use 3 here. 42 divided by 3 is going to give me 14. And 9 divided by 3 is going to give me 3. So in this case, I actually end up with 14/3. In this case, they did not want me to simplify it. So please be super careful. If you work it all the way through and you are sure that you have the correct answer, and you don't see that answer choice, go back and double check and see if possibly they didn't want you to reduce it or they wanted you to leave it as an improper fraction. Okay, our next question has to do with pizzas. It says Jake and 4 friends each ate 3/4 of a pizza. How many pizzas did they consume all together? Okay, be super careful. This says Jake and 4 friends. That means that there is a total of 5 people. Be very careful and look for that. And it says that they each ate 3/4. Well, 3/4 is equivalent to 3/4. So anytime you see the word quarters, it's talking about fourths. So how many pizzas did they consume in all? Well, in order to figure that out, there's 5 people, and they each ate 3/4 of a pizza. So remember, in order to multiply this, I need to put that 5 over 1 to show it's 5 wholes. And then I'm just going to multiply straight across there. And I've got 5 times 3 is 15. And then 1 times 4 is 4. Well, that is answer A up here, 15/4. They consumed 15/4 of pizza in all. Yes, you could have made this into a mixed number. So if you had already gone to that step and done 15 divided by 4, you would have found that that mixed number equals 3 3/4. Oops, I'm off the screen there. So that's not even one of your answer choices, though, because they just wanted the improper fraction. So just take a look at your answer choices so you know what kind of answer they're asking for. Okay, here's another pizza problem. In the refrigerator was 2/3 of a pizza left over from a party. If you ate 4/5 of the leftover pizza, how much of the original pizza did you eat? So there's 2/3 of a pizza left over from a party, and you ate 4/5 of it. So if there's 2/3 and you eat 4/5 of it, then I have myself a great fraction multiplication problem here. And I know that 2 times 4 is 8. And 3 times 5 is 15. So if I look at my answer choices, that is answer choice D. So here, Raj was given 3/4 of a cake, and he ate 3/4 of that part of the cake. How much of the whole cake did he eat? So he had 3/4 of the cake, and then he ate 3/4 of the cake. So how much of the whole did he eat? So we're going to set this up as a fraction multiplication problem, and we're going to say 3/4 times 3/4, and as I multiply across, I know that 3 times 3 is 9, and 4 times 4 is 16. So my answer choice is answer choice C. Now, moving on to the next problem here. We're talking about jelly beans. It says, how many 1/6 cup servings are in 6 cups of jelly beans? So I want to know how many 1/6 cups are in 6 cups. So I actually have 6 divided by 1/6. So I could draw a model here. So there's 1, 2, 3, 4, 5, and 6. And if I chop each of those 1 cup servings into 6 cups, and those are not beautiful, but so I chop those into 6 cups, or sixths in each cup. How many 1/6 do I have here? Well, there's 6, 12, 18, 24, 30, 36. So I have 36 1/6 cup servings. Some of you, yes, I know, are working standard algorithm. If you were working standard algorithm, then yes, you would have used this equation here to work that. But remember, that is not a a 5th grade standard. It's definitely not 3rd grade. So you don't have to worry with this. You could draw this out with a model. Okay, the next one. After the party had ended, 1/4 of a cake was left over. If 3 guests wanted to split the cake, how much would each get? Okay, so here's my cake, and I know that it's in 4ths because there's 4 pieces there, and it tells me up here that there's 1/4 left over. If 3 guests wanted to split that leftover cake, I'm going to split each of these into thirds because there are 3 guests. So there's now thirds there, thirds, thirds, thirds. How many pieces what would one piece represent? So I have a total of 12 pieces here, and if I'm only eating 1, I have 1/12. All right, for the next one, let's see if I can get this on the camera here. This one's a big one. All right, it says a baker has 5 pounds of flour. How many cakes could the baker make with the flour if each cake takes 1/4 of a pound of flour? All right, so I have 5 pounds. So I'm just going to draw one big block here. So here's my 5 pounds. There's 1 pound, 2 pounds, 3 pounds, 4, 5. So let me label those. 1, 2, 3, 4, 5. There's 5 total pounds of flour. Let me try and get me on the paper there. Okay. And it says each one is going to take 1/4 of a pound. So if each cake takes 1/4, I'm going to split this into fourths. So there's 1/4, there's 1/4, there's 1/4, and there's 1/4. So how many pieces do I have now? If I start counting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have a total, I can make a total of 20 cakes by splitting each pound of flour into a fourth, and then I knew I had 5 pounds. Okay. So here's the next one. This one's talking about, oops, let's see here. This one's talking about pies. Okay, it says 8 pies are cut into 1/6 slices. How many slices of pie are there? Okay, well, instead of drawing 8 pies, because I'm not really good at drawing circles, I can draw rectangles pretty well. So I am going to draw my pies here. These are going to be new rectangular blueberry pies. So 8 pies. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 pies. And I am going to cut each pie into sixths because it tells me 1/6 slices. So let's see here. All right, there's 3. So then there's 1/6. Well, we'll do it this way: 1/6, 1/6, 1/6, 1/6, and 1/6. So I made sixths there. So how many total pieces do I have now? I had 8 pies and I split each pie into 6 pieces. So if I start counting here, I'm going to find out that I have 48 pieces of pie. That's a whole lot of pie. So if I went and counted these, 1, 2, 3, 4, 5, 6, and I counted all the way, I would find out over here that there are 48 pieces. Some of you, if you're working this using standard algorithm, then yes, you would have used this for the division. But remember, that is not a 5th grade standard. Okay. So, taking a look at the next question with the gallon of milk. So, if you need to find that on your paper, go ahead. And this one says, if 1/4 a gallon of milk is shared equally between 6 friends, how much milk will each friend have? So, here's what I'm trying to solve. I'm trying to solve 1/4 divided by 6. So here's how I can work this out. So we're going to draw, here's our milk. I know, purple milk. Maybe it's grape milk. I don't know. That's kind of gross. Let me scooch the camera over a little bit here. So I need to first figure out my 4th gallon of milk. So I'm going to split my milk into fourths, because it tells me up here I have a 4th gallon left. So there's 1/4, 1/4, 1/4, and 1/4. And I can't just deal with 1/4 because we know that the rest of the gallon of the milk has to go somewhere. So we always have to talk about things as compared to the whole. So now I'm going to split this into 6 pieces because each of these friends, there's 6 friends. So let's split this up into 6 different pieces here. So there's 1, 2, 3, 4, 5, 6. If each person gets 1 share of it, because it says how much milk will each friend have. So 1 piece of this, I know they're going to have 1 piece of it, but how many total pieces were there in all? Well, if I counted all these, I know that there would have been 24 pieces here. So they would have gotten 1/24 of the whole gallon, which is D. Okay, moving on. And remember, if you need to stop the recording so you can try a problem and then look for the answer, that's a great strategy. So don't hesitate to hit pause and keep going afterwards. Okay, so now we're going to move from milk to banana caramel cream pies. So it says, how many pieces of pie will you have if 4 banana caramel cream pies are sliced into 1/8 servings? Okay, once again, I refuse to draw circles. I am a horrible circle drawer. I have 4 banana caramel cream pies. Probably should have used a color other than blue, but maybe we should have used yellow. So here's my pies. There's 1 pie, 2, 3, and 4. So there's 4 pies. Each of those pies is going to be sliced into 1/8 servings. So I have to split these into 8ths. So I'm splitting every single pie into 8 pieces. So how many total pieces, remember they're asking me, how many total pieces do I have here? So when I start counting, I'm going to count all the way up, and I'm going to find out that I have 32 pieces of pie. So my answer would be D, 32. All right, so for the next one, it says, if a 30-foot rope, let me see if I can get that a little more clear. There we go. If a 30-foot rope is divided into 1/4 of a foot pieces, how many pieces of rope are there? Okay, so what we're actually saying is 30 divided by 1/4. Well, here's where you might want to use a little bit of just some logic here. Because you know that in 1 foot, you're going to have 4 pieces. So if I have 30 feet of rope, how many pieces how many 1/4 sections can I change that into? So I could do this, I could solve a lot of different ways. I could draw out a number line and go all the way to 30 and then split each of those. I could do my boxes and I could say, okay, here's my whole rope, and you could draw out 30 boxes going this way and then slice all of those. And I think that's a great strategy, because if I had 30 boxes going this way, I'm not going to actually draw them out. And then I knew that I needed to slice each of those 30 feet of rope into 1/4 sections. How many pieces of rope would that give me? Take a look at your answer choices at this point and use some process of elimination. 60. Well, I think I would have more than that, because if 1 piece of rope equals 4, if 1 foot equals 4 pieces, 30 feet would equal how many pieces? So I'm thinking I could say 30 times 4. And sure enough, I do have the answer choice of 120. Some of you are using standard algorithm again, which, remember, it would look like this, and then you would have to multiply by the reciprocal, which would quickly tell you that it would be 120 pieces. Remember, this is not a 5th grade standard. You do not have to know how to do that. But if you can figure it out with a model, that is great. But I know some of you are using this, and I just want to make sure you're using it properly. Okay, the next one. If 20 is multiplied by a number between 0 and 1, the result is A less than 0, B less than 20, C greater than 20, or D between 0 and -1. I don't know about you guys, but these make me very anxious. So here's what I do. If 20 is multiplied by a number between 0 and 1, well, what numbers come between zeros and ones? So it has to mean a fraction. Fractions are the only things between 0 and 1. So I'm going to get rid of this, and I'm going to say, if 20 is multiplied by a fraction, the result is, well, I know that if I multiply 20 by a fraction, it's going to be less than 20. So that would be answer choice B. It's not going to be less than 0 because if I'm saying 20 times 1/2, I'm going to have 20 1/2 pieces. Put times 20. So I'm still going to have something. It's going to be more than 0, so it can't be less than 0. It's not going to be greater than 20 because I'm not taking the whole piece. I'm only taking a part of it. And between 0 and -1, well, if it can't be less than 0, that would rule that one out as well. So B is our best answer choice there. Okay, and here's some models. And this one says, which equation best matches the model? So I am going to use my trusty colors here. And I see that going horizontally, I have 3. So there's 1, 2, 3, 4, 5 pieces that way. And I see that I have 3/5 of those shaded in. And then going vertically, there's, oh, oops, I'm doing the wrong way. There's 1, 2, 3, 4, 5, 6, 7, 8. And we're going to ignore those blue lines and pretend like I didn't do that. Because 1, 2, 3, 4, and 5. So that tells me that I have 5/8 of that one shaded in. So the first thing I'm going to do is look at my problems, and I'm going to see if I can find something that has 5/8 times 3/8. Well, A is, 9 plus 2, that's not it. B, 3/8 times 10/5. Well, I have the 3/8. Well, that's 5/8. Oh, that's not it. Good grief. 3/5 times 5/8 equals 15/40. Well, that could be it. I'm going to put a little check mark, and then none of the above. Well, it could be that, but I'm not sure because I still have to check this one. Oh, I'm off the screen. Sorry. So in order to find the answer to this, I need to know how many of these guys have both colors in them. So I can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 of those that have both colors, and in this there are a total of 40 blocks. If I counted all of those, there would be 40 blocks. So I know that my product here is 15/40, which if I look back, oh yeah, that is answer choice C. Okay, another one like that. Your best case is to count these. 1, 2, 3, 4. And I can see that 2 of those are shaded in. So that would make 2/4 over there. And then 1, oh, and I forgot to count them. 1, 2, 3, 4, 5, 6, 7. And there's 4 shaded in, so that would be 4/7. So let me look at my answer choices, and before I even do that, let me figure out what my product would be here. I've got 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, and I know that there are a total of 28 boxes there. So I should be looking for something that says 2/4 times 4/7 or 4/7 times 2/4. Let's look at our answer choices and see. 8/14 times 6/12. No, that's not it. I have 6/8 plus 8/28. No, that's not it either. The next one I have 4/7 times 2/4 equals 8/28. Well, that's exactly what I came up with. Or none of the above. Well, I know it has to be C. So for this one, it asks which equation describes the model. And if you take a look, the first thing I can see very quickly up here is how many holes I have. I have 1, 2, 3, 4. I have 5 holes. And each hole is split into 1, 2, 3, 4, 5, 6 pieces. So each of those holes is split into 1/6 pieces. So I have 5 holes and each is divided into 1/6. So here I have 1/6 divided by 5. Nope, that's not what I'm doing. Here I have 5 times 6. No. Here I have 5 and each 5 is divided into 6 pieces. Well, that could be it. And here I have 5 divided by 6. Well, I do have 5 holes and each hole is divided by 6, but it's not divided by 6 holes. It's divided by little 1/6 pieces, so it can't be that. So that leaves us C. Okay, and here is our last question for the IA4 review, and this is a matching one that when you've completed this in USA Test Prep, you would have to drag and drop these. Okay, so let's take a look, and I've got some extra paper here that I'm going to use. Our first problem is 1/2 divided by 4. So remember what that would look like would be taking 1/2 and dividing it into 4 pieces. But remember, I have to acknowledge the entire thing, that there's a whole, so I have to divide both halves. So then how many little pieces do I have? What would one piece be equivalent to? One piece would be equivalent to 1/8. Okay, so then the next problem says 1/3 divided by 4. So if we use the same model and we divide this into thirds, and then I have to divide those into 4 pieces, which I'm going to divide this way this time. Oops. Then what does one little piece represent? 1/12. So hopefully you can see the pattern here. When you divide a fraction by a whole number, your quotient is going to be a fraction. Unless this is an improper fraction and you have your numerator is bigger than your denominator, then you could get some other kind of crazy situations. All right, so then we had 1/4 divided by 5. So if I use the same little model here, so I'm going to have 1/4. So let me make fourths here. So there's my fourths. And then I am going to split that into 5 pieces. And then what would one piece equal? 1/20. So I bet a lot of you are having a light bulb moment and you're saying, oh, I see it now. So you can, when you divide a fraction by a whole number, most times you're going to end up with a fraction unless you're dealing with an improper fraction. Okay, so then the ones at the bottom of the page, So let's start with the next one here, which is 3 divided by 1/4. All right, well, if I have 3 whole pizzas, oh, and look, I told you I can't draw circles. I'm going to show you. I'm proving it. So if I have 3 whole pizzas and I divide each pizza into 4 pieces, so fourths, how many total pieces do I have there? Well, I end up with 12 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the next one is 4 divided by 1/2. So I could do the same thing. So there my 4 wholes are. And if I divide each of them in half, how many halves do I have? Well, I can count and I see that I have 8 halves. Then I have 5 divided by 1/4. So 1, 2, 3, 4, 5, and then if I cut each of these into fourths, how many pieces do I have here? Well, if I go in and count, I see that I have 20 pieces. And then the last one, 4 divided by 1/4. Same thing, if I have 4 wholes and I divide each of those into fourths, how many pieces do I have? If I count, I have 16 pieces. So here you can see when you divide a whole number by a fraction, you're going to end up with another whole number. So those are the 2 different situations. So we have dividing a whole number by a fraction gets you a whole number. Dividing a fraction by a whole number gets you a fraction. Alright, so hopefully that will help you guys with your IA4, which is coming up next. Alright, friends, hopefully that will help with your IA4 as you prepare to take it next week. Remember, if you have any questions, don't hesitate to let your math teacher know, or go to Content Tutoring on Friday morning to get some more help if you've got a specific question. Good luck, guys, and I'll see you later.